Okay, we're going to get started. Our next talk is an introduction to container security. Our speaker is Thomas Cameron. He's a Red Hat solutions architect. So without further ado, I give you Thomas.
Thank you. Thank you very kindly. My name is Thomas Cameron, and I am the Global Solutions Architect Leader at Red Hat. So I'm responsible for all of our field technical sales staff. So all the pre-sales engineers, pre-sales consultants around the world are my internal customers. I try to keep them up to speed on technology and methodologies for helping customers and things like that. As we discussed before we got started, there's kind of an alphabet soup after my name. I am a technical resource inside of Red Hat. Been with the company for about 10 years, and I have been in the IT industry since 1993. So been doing this for a while, but I have certainly learned the longer I work at Red Hat, the less I feel like I know, because I work with some incredibly smart people. And every time I start to get a little big for my britches, I just go and visit engineering in Westford and come back, and I'm like, yeah, definitely Linux admin. So let's talk about what we're going to talk about today. Today is going to be a repeat, actually, of a presentation that I did at All Things Open back in October. I found that when I was talking to folks about containers, there were invariably questions that came up about container security. And, the stock response is, well, containers, can be secure because they take advantage of a lot of functionality in the Linux kernel, and they take advantage of some of the features of Linux, kernel namespaces and security enhanced Linux and things like that. And people are like, yeah, that's cool, but what does a kernel namespace do? And I was like, it's a namespace that the kernel spaces names. And I realized, I sort of understood at a fairly high level what kernel namespacing was, but I started really digging into it, and the more people I talked to, the more people I found that were like, yeah, I kind of get it, but I don't really get it. So I decided to come up with a fairly simple overview. We're not going to dive super deep. This is just the fundamentals of container security. So I'll talk a little bit about who I am, about what Red Hat has been doing around containerization. We'll talk about what containers are, how they work, what they aren't, and talk about some of the myths that I have heard from folks who are exploring adopting container technologies. And then we'll talk about the nuts and bolts of what container security is, what makes up all the components of container security, including kernel namespaces, control groups, a little bit about the Docker daemon and how it helps to keep you secure. And then we'll talk about Linux kernel capabilities, security enhanced Linux, and then I'll go over some tips and tricks, what to do, what not to do, and talk about our conclusions. So by way of introduction, as I said, I've been with Red Hat for a long time. I've been in IT since 1993. I actually changed careers in 1993. I was a police officer for several years. I have a pretty strong academic background in security and law enforcement, and I have professional experience in law enforcement. I realized that I couldn't afford to pay my bills as a police officer and went off and became a computer geek. So now I'm a computer geek. Been with Red Hat since 2005, got a whole slew of professional certifications. My first job out of when I changed careers was in a Novell shop, so yeah, I'm dating myself right there. But I was a C&E back in the day, back when that was like the thing, right? And I went to work for Microsoft for a while. I got better. So I was an MCSE and an MCT, a Microsoft Certified Trainer. So I've been doing this for a long time. I do spend a lot of time focusing on security in organizations like banks and manufacturing companies, e-commerce companies, and things like that. I've helped Red Hat customers for over a decade now working on these issues, working on security issues. And as I mentioned earlier, man, I totally recognize I don't know everything. I know a lot, I've been exposed to a lot, but again, it's hard to know everything. So kind of in a nutshell, I'm just a big old nerd. So let's talk about where Red Hat fits into the container ecosystem. We have actually been working on containerization since before 2010. We made the Makara acquisition. We bought a company that was doing platform as a service back in 2010, and they were using Linux control groups and security enhanced Linux for process isolation. But honestly, this is really before containers, as we think of them today, was really a big thing. But we've been doing this for a while. We're fairly familiar with, well, I would say we're expert, because I talk to those guys sometimes, and I, again, walk away feeling like an idiot. But So we bought Makara, we rebranded that as OpenShift. And so now you may have seen that Red Hat has a platform as a service offering called OpenShift. There's 3 versions. There's OpenShift Origin, which is the upstream open source. Anyone can download it, compile it, play with it, do whatever. It's kind of the Fedora land version of OpenShift. Then there is OpenShift Online that Red Hat has been offering as a service for several years now. You can go to openshift.redhat.com and you go through a really simple web UI and say, I need this much capacity and I want this application framework and maybe this pre-canned application, and you can have your application up just like that. And then we have OpenShift Enterprise, which is for deployment on a customer premise behind the firewall. Now, originally, OpenShift used what we called cartridges, and they were units of compute that were basically segregated by security enhanced Linux, by Linux control groups, and kernel namespaces. In about 2013, Docker really started to get its stride, started to do really well, and we realized it really makes sense for us to change away from what we had been doing to what Docker was doing. So we adopted Docker as a technology in our PaaS offering back in 2013. We are a top contributor to Docker. Last time I checked, this was back in October, we were the #2 contributor to upstream Docker behind only Docker itself. So we got a fair amount of experience there. And as you know, if you've been to any cloud track at the conference at Scale, the adoption of Docker is incredible. They have done a phenomenal job. It's good technology, good community. The company itself is doing real well. They've been through multiple successful VC rounds, and the laundry list of people who have thrown in behind Docker is amazing. Red Hat is grateful to be on that list as well. And even Microsoft. I was in the Microsoft session, the Microsoft Azure session yesterday, and they were like, yeah, we're going to be doing Docker containerization on Windows Server 2012. First they ignore you, then they laugh at you, then they fight you, then you win. So, I'm sorry? I'd like to see them try. The comment was, and expand and make it proprietary. So let's talk a little bit about what containers are. So containerization, now I'll be talking specifically about Docker, but these concepts should be fairly universal no matter what you're using, whether you're using LXD from Ubuntu or whatever. But basically, it's a technology that allows for applications, whatever those apps are, whether it's web or database, app server or whatever, to be abstracted from and in some cases isolated from the underlying operating system. In the case of Docker, the service can launch containers regardless of the underlying Linux distro. And containers can absolutely enable some amazing application density. Since you don't have the overhead of virtualization where you've got the full operating system with the same set of libraries getting loaded for every VM, it's really, really lightweight. And when you factor in the architecture that it's just the bits that you need for the application, and you also take into account the capabilities of Linux control groups where you can give very fine-grained control over how much resource or how many resources each application or each container is going to get, you can get some phenomenal utilization. And, I joke, the same container can run on different versions of Linux. Ubuntu can run on Fedora, and CentOS can run on RHEL. Dogs and cats, human sacrifice, mass hysteria. But it's really cool. I'm a Red Hat guy. I've been with Red Hat for a long time. It's just what I'm most comfortable with. I can't tell you how many times I've spun up a container and it's like, oh yeah, the underlying technology on this one was obviously built on Ubuntu. That's cool. I run it on my Fedora box or on my RHEL box and it's like, no big deal. So it's really, really an awesome technology for application developers. So how do they work? Or actually, no, maybe not. Containers make it easy for app developers to build and deploy apps. It's not really that mass hysteria that we were talking about earlier. So the question then becomes, well, what are containers not? Because one of the things that does concern me a little bit, and frankly frustrate me a little bit, is this like, we're going to containerize everything, and everything's going to be awesome, it's going to be wonderful, and it's going to solve all the problems in IT. Maybe not. Containers are not a panacea. They are not the cure to all that ails you. And containers are not fit for every application. Not yet. Maybe not ever. I don't know. I never say never, except when I say I never say never. because you never know, right? I mean, somebody's going to come up with something that's like some huge, massive, awesome container. What we really hope for when we're kind of thinking about what would be the best case is, what we really hope for is for the big software vendors, the big enterprise software vendors, third-party shops like SAP and Oracle and, fill in the blank. Wouldn't it be awesome if instead of getting a DVD ISO image that's got a freaking install.sh that does all kinds of crazy non-packaged weird stuff all over your file system that you don't know what it is, wouldn't it be cool instead if they just went, here's a container, go. That would make life so much easier. So, will we ever get there? I don't know. I hope so. I hope so. And most importantly, containers are not virtualization. I think that in a very, very simplified way, they are the next logical step in the whole, physical, virtual, then high density move, but they're not virtualization. You can run containers on bare metal, on an OS directly on bare metal, or you can run it in VMs. So virtualization is most often a component of an environment that has containers, but the two are actually separated. So let's talk about container security. There are multiple layers that are involved in securing your container environment. It's not a simple environment. When you think about all the different things that you want to do to harden your system, the system that's running the containers themselves, the networking stack in front of the container, how we do network address translation from real public IPs to the internal private network that containers use, there are a whole lot of moving parts there, and there's a lot of opportunity for friction between those moving parts. So let's talk about what all of those little components are and maybe get a good handle on how we can reduce that friction. So containers use several mechanisms for security. Linux kernel namespaces, which is a really fascinating set of technologies, and I'll show you some examples in a little while of that. Linux control groups for that fine-grained resource control, how much memory, how much CPU, how much I/O, things like that. The Docker daemon itself, when you're using Docker as your containerization platform. A fairly infrequently discussed feature of container security is Linux capabilities, or libcap. I'll talk a little bit about libcap. It's a pretty cool way of saying I'm going to limit the capabilities that a process has, even if it's running in the context of root, and I'll show you some examples of that. And then Linux security mechanisms like SELinux or AppArmor. Now, I'm an SELinux guy. So for me, I will talk about SELinux, but any sort of pluggable security model like AppArmor or GRSec or anything like that could be used. Now I'm going to break out of this for just a second. How many folks disable SELinux in their environments? Bad users, bad. Go to YouTube, look up SELinux for Mere Mortals. It's a presentation that I did at Red Hat Summit. It's 45 or 50 minutes long. If you watch that presentation and still shut off SELinux, I'm going to have to smack you. I'm sorry, I love you, I do it out of love, but go watch SELinux for Mere Mortals. It's a 1 hour overview of SELinux. And do you have a comment? Yeah, I've actually done it like for 3 years. It's been the top rated session at Summit for the last 3 years. So it's, at the risk of thumping on my chest too terribly much, it's a pretty good presentation. So SELinux is, to be clear, an integral and very important part of container security when you start doing massive scale. When you start doing platform as a service where you're running this stuff across really large environments, don't turn off SELinux. It's really important. So, like I said, I was having conversations with folks about container security, and it was always just like, oh yeah, well we do kernel namespacing, and that helps with security, and then the conversation would go on, and then one day somebody was asking really specific questions, and I was like, how do I describe what kernel namespaces do? And so I came up with a couple of ideas. So let's talk about what they are first. Namespaces are just a way to make a global resource appear to be unique and isolated. The namespaces that the Linux kernel can manage include mount, namespaces, process ID namespaces, Unix time sharing systems namespaces, UTS, interprocess communication namespaces, network namespaces, and user namespaces. I've seen several folks taking pictures of the slides. You are absolutely welcome to do that, but these slides are posted on the Scale website. You can have them, or you can go to my, my people page, people.redhat.com/tcameron, and you can download them from there. So those are the different namespaces which can be managed by the kernel. And let's talk about what that means. So the first one I want to talk about is mount namespaces. Mount namespaces really just allow a container to think that a directory which is actually mounted from the host OS, an existing directory on the host OS, is the exclusive domain of what's going on in the container. The container is not aware that that's actually a file system from outside of that container space, and you could potentially mount it within the container, read write with root privileges and so on. When you start a container with the -v and then the host path, like the actual directory, and then where you want it to be mounted inside of the container, so -v/var/www/html:/var/www/html, for instance, you can spin the container up so that it thinks that, oh yeah, that's mine and no one else has it and I'm not even aware of anything else. And then you can flag it as read write or read only. And so then it sees that directory in its own namespace, and the cool thing about it is that there's no exclusivity. You can do a mount namespace of one physical directory across multiple containers, and that works really, really well. So as an example of that, can y'all see that okay? Okay. So as an example of that, I'm logged on to my laptop, my T540, and I cat var www.html index.html, and I see, yeah, it's a silly web page, right? Just that's the actual file that exists on my file system. So I do docker run -v, and then I do var www.html, and I'm going to mount that within the container on var www.html, and I'm going to fire up a Fedora container and execute the command bash. And then you notice that my prompt changes from being root on my T540 to being root within my container. And if I cat that same file, I see that it's there. In the context of this container, the container is not aware that that's actually not a native file system. I can run that container. In fact, I did run that container from within root's home directory. Not necessarily a good idea, running stuff as root, but I did it just for sake of examples. But my point is, it abstracts and isolates what's really there and tells the container, nope, it's all you. It's all yours, don't worry about it. Don't worry about anyone else on the system. So, I have a pretty good understanding of this, but what would be a security advantage of doing that? And this is the audience participation point. Why would that be a good thing from a security standpoint? It can access your file system. Let's be real clear. If I had mounted that RW, it can access your file system. But one of the beautiful things about it, I'm sorry, and the comment was, well, it can't access your file system. And actually it can, but you have control. You can say, nope, only read only. You're not going to be able to modify it. Yes, sir. Exactly. You have jailed that container to where you're going to give it access to one specific directory. It can't go up the file system to the container. That's the root of the file system. So from a security standpoint, it's a heck of a lot better doing it this way than trying to do all kinds of crazy bind mounts or weird stuff like that, or chrooting. Chrooting's fine, don't get me wrong, I like chrooting, but this is really strictly locked down. Okay? All right, so process ID namespaces. A PID namespace, or PID namespaces, really just lets the container think that it is a completely new instance of the operating system. So when you start a container on a host, it's going to get a new process ID on that host, but PID namespaces means that the container thinks that it's in its own process tree, and whatever the command is that you started that thing up with is going to be process ID 1, which is a little bit weird because we're all used to process ID being 1, being, you know, init or something like that. But in this case, I'm going to launch a Fedora container running bash, and I'm going to run the psax command. So I run that command. So I do docker run -it Fedora and execute the command bash. When I do a psax, process ID 1 inside of the container, it thinks I am alone, I am my own operating system, I know nothing about anything else, but my process ID 1 is bash, which we all know is actually, you couldn't boot a system that way. But again, from a security standpoint, how awesome is this? That container doesn't see squat on the rest of the system. It's like, oh, I'm all by myself and I'm safe and secure. And now, over on the host though, when I run a PSAX, I actually did PSAXF, but you can see that my Docker command is actually process ID 18557. That's an example of that namespace. That's an example of the Linux kernel going, no, really, that's process ID 1, you're all by yourself, you cute little thing, you're all by yourself and you're secure. Where on the system, you may have dozens or hundreds or even thousands of Docker instances. So, does everyone understand why that's a really good thing from a security standpoint? The container is not even aware that there are other processes running on the system. So that's a beautiful thing from a security standpoint. It's totally isolated. You can't easily, anyway, do like a buffer overflow of another process because you don't even know that the process is there. User namespaces. When you start a container, assuming you've added your user to the Docker group, you start it as your user account. Now, I did an example earlier as root. Don't do that. Do it as your user. I blew my machine away, put a fresh install on to do the demos, and was stupid. Forgot to put a user account on it. So you start Docker as your user account, and in the following example, I'm going to start the container as tcameron because I realized halfway through building my slide deck, I was like, oh, I shouldn't be doing this as root, and I added the account. But once a container is started, the user inside the container is root. So in this case, I'm sitting there logged into my console. My ID is tcameron. I'm user ID 1000. I'm a regular user, no root privileges or anything like that. I run docker run it Fedora with a command of bash. I'm still on the same machine, still on the same console, but when I run ID inside of the container, I'm omnipotent. I am root. Now, the cool thing about this is that means that within your container, you can do whatever you need to do, right? But that's only within your container. If you try to go, ooh, I got root on the system and try to do something else, you're not even aware inside of the container that there are other things going on outside of your container. So again, from a security standpoint, there's a bright line between what you can do. Even with root privileges inside of your container, you can't affect the underlying host. Yes, sir? What happens if you configure what? You shouldn't be able to. I'm not going to say you can't because like someone out here will go, well, actually. But remember that even though you have root privileges, oh, I'm sorry, repeat the question. Thank you. The question was, what happens if you trigger a kernel crash within the container? And the reality is, because we're using namespaces, because we've isolated the container and this root account doesn't actually have root privileges on the underlying host, you're not going to have, for instance, you're not going to have access to the sysrec trigger proc file system entry to trigger a crash. So at most, you would be able to crash the application within the container, which is kind of a restart the container. Does that make sense? Yes, sir. Yes. Right? So the question is, if I'm root inside of the container, what would happen if I ran a kernel exploit that I found and tried to, well, here's the beautiful thing. You're not really root. You're only root in the context of the container. So in many cases, not all, in many cases, a lot of the things that you can get, like if you have local access, you can crash the kernel, blah, 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 that doesn't necessarily work for user space. In other words, a non-privileged user wouldn't be able to do it. Now, if you did find an exploit that was a user space, or a user privilege that you could crash the kernel, it will probably take it down. If you can execute it and it does work from user space, it'll probably take it down. At which point you got bigger problems. So the question is, will it take down the container processor or will it affect the host? Depends on the exploit. If it's actually truly like a kernel exploit that's going to cause a panic or something like that, you're going to take the host down. Yeah. Here's the thing. If they have access to your system, whether it's physical access or shell access to the system, it's going to greatly increase your security vulnerability surface area, right? Because then they can do fork bombs and they can do all kinds of stupid stuff that, that's bad stuff. The best answer there, unfortunately, is keep your systems up to date. Really pay attention to the security mailing lists. Keep your systems up to date. I know that's not a perfect answer, but there was another question over here.
Yeah, I'm assuming that the container can be constrained so that like a user using it can't endlessly consume CPU, RAM, disk space, whatever.
I'll talk about that in a little while. The question was, can a container be constrained so that one bad actor can't overwhelm the system? And the answer is yes, absolutely. And I'll talk about that in a minute. All right. So again, security implications of user namespacing. The main thing is just isolation. Even though you give somebody sort of a virtual root environment where they have control in their container, it isolates giving those escalated privileges to somebody that's got system-wide access. All right, network namespaces. Similar concept. Network namespaces allow a container to have its own IP address independent of the host. And these addresses are not available from outside of the host. So in this case, it's private networking, very similar to what you get like with libvirt or other other virtualization. But in this case, the Docker service is smart enough to set up an IP tables masquerading rule so that the container can get to the rest of the internet. So in this following example, what I'm going to do is I'm going to spin up a container, and I'm going to run ifconfig, or in this case, IPA show, and you'll see that that my physical host, and I did this a little bit backwards. So I'm on the, if I use docker inspect and I query for the network settings IP address, then I get that it's a 172.17.0 address. But my machine, my laptop wasn't even hooked up to Ethernet. Like when I do IP address show on my Ethernet interface, there's no IP address at all. So this is a totally separate networking namespace. It's isolated from the external network. In this case, I don't even have an external network, but that's just a virtualized private network that's behind what will eventually be an IP tables masquerade rule so that it can get out to the network. Yes, sir. The question is, can you do 802.1q trunking within the network namespace? I have read that there is work being done on it. I don't know if it's complete, but what would the benefit of that be? Like, why would you, what are you looking to accomplish? Yeah, I mean, that's a fair point. If you do have that, then you can directly address your containers, and then you don't need Docker to do all that stuff. But my question to that would be, but Docker has got an entire large community around developing that networking code and the IP masquerading code, and they're actually pretty good at what they do. I think I'm pretty good at what I do, but I guarantee you I'm not nearly as good as all of that community. So, yes, sir. Okay. Okay, so the comment is in a very large scale environment where you're using, you said VPN concentrators in containers? Open VPN endpoints. And you start running into limitations with IP tables. Okay, that's a fair point. That's a fair point. Yeah. Yeah, Docker may not be the best solution for that. So you don't, yeah, that's fair. Yeah, so the comment is you don't have to use network namespacing. You can actually directly address the Docker containers. Yeah, that's fair. That's fair. Was there another question?
Is there any work being done to get Docker working with NF tables instead of IP tables?
I don't know. I don't know. Send me an email at thomas@redhat.com. Yeah, I've been there that long. Send me an email at thomas@redhat.com and I'll find out. I haven't heard.
I was under the impression that NF cables was like the replacement.
The next big thing. Yeah, so the question was, is any work being done to allow Docker to use NF tables instead of IP tables? And unfortunately, I haven't heard one way or the other. So, yeah, by the way, if you have questions, I'm thomas@redhat.com. I'm real easy to reach. All right. So security implications of network namespacing, it should be relatively obvious. We can segregate those containers. We can keep them off of the network. We control ingress and egress rules through IP tables so that it's isolated and we know for sure what's going to get in and what's going to get out. So IPC namespaces. IPC namespaces, really same thing but with inter-process communications. So my container doesn't have any IPCs mapped because I just spun it up, right? If I spin up my container and I do IPCS, there's nothing going on. There's no inter-process communications because all this is just running bash. It doesn't have any applications that are talking to each other. But on my host, when I run IPCS, you can see I've got zillions of processes that are communicating with each other. But again, that container, if I go back a page, that container thinks it's all by its lonesome, running on its own bare metal. It doesn't have any knowledge of all of those IPCs that are running on the host. So from a security standpoint, the security implications there are you don't even have inter-process communications that are exposed to that container. So you don't, like if a bad guy does get control of that container, they don't have the ability to go and start trying to do attacks or anything like that. So again, isolation and segregation is not a bad thing. UTS namespaces or Unix time sharing system namespaces, again, let the container think it's its own separate OS with its own host name and its own domain name. So on my host, on my laptop, when I run the host name command, I get my fully qualified domain name. It's t540p.tc.redhat.com. But then when I fire up my container and I run host name, on that same machine, it's got a randomly generated string for a host name. So again, the container thinks that it's its own machine. It is not aware that it's actually a container running on a host. So again, from an isolation standpoint, if somebody does break into it, they don't get any identifying information about what the underlying host is. Like you don't want to say, yeah, well, the host name is host XYZ and mycorp.com, because then they're like, now I know where to go attack, right? So isolation and security through keeping it segregated from the host operating system. So that is namespacing. Those are the capabilities that the kernel has to segregate out and to isolate what's going on inside of a container process from the underlying operating system. So let's talk about a different capability, which is control groups. So control groups really just provides a mechanism for either aggregating or for aggregating / partitioning sets of tasks and all of their children into hierarchical groups with specialized behavior. Really, this allows for various system resources to be bundled into a group, and I can apply limits to that group. So disk I/O, CPU usage, memory usage, network use, all that kind of stuff are contained into one address space or one process space. And the cool thing about using control groups is everybody thinks in terms of, oh, well, if I use Linux control groups, I can make sure that the one badly behaved neighbor doesn't take over the whole system. And that's absolutely true. And that's certainly a very common use for control groups, is to make sure that you don't get some bad person that's doing something silly like setting off fork bombs inside of your container and taking the whole machine down. But the flip side is also true as well. Because we use control groups for containerization, we also use control groups for virtualization and all kinds of stuff. What it also allows you to do is use your hardware to the absolute maximum. So if I know for sure that I've got a fixed amount of memory, let's say 16 gigs of memory or 32 gigs of memory, whatever. I know that when I spin up whatever it is, VMs or containers or whatever, and I know what I'm going to be allocating to those control groups around those, then I know to the specific number of containers how many I can run on my machine. So instead of this kind of like, well, we're going to throw some more VMs on, or we're going to throw some more, in this case, containers on, and we're going to watch it and see if the machine is okay. No, in this case, I can divide up my system into exactly the number of containers that I know it will support, and I know that it allows me to do forecasting, it allows me to do scheduling, it allows me to know when I'm going to run out of capacity, when I need to buy new servers and things like that. So control groups are pretty awesome. And again, it ensures that if a container is compromised or just has poorly written code, like somebody does something that gets into a race condition or something like that, there are limits in place which minimize the risk that that misbehaving container is going to hurt the rest of the host. Notice that when I run the command system control status docker.service, I get the control group and slice information. So you can see that when I've got a container running on my machine, it's actually got its own Docker service system slice. And so I can go in. Now, by default, when you spin this stuff up, we do put it in its own control group, but we don't put any limits on it. Doing control groups, like actually manipulating control groups, I could spend like 8 hours on that. It's a fairly complex topic, so I'm not going to get into all of the nuts and bolts and the nitty-gritty of doing it. But be aware that at least on Red Hat-based systems, we automatically assign each instance to its own control group, and if you do start needing to get really restrictive on how they're going to access the systems, you can go in and put limits in place. You can go and look in the sysfs cgroup sudo directory to see what the resources are that are allocated to your containers. Now there are like 8,500 entries in that directory. So again, unfortunately, it's kind of not practical for me to try to go into each of them, but you can get information about memory, CPU, block IO, network IO, and so on in there. So if I go and I look in /sys/fs/cgroup and I do a find pipe word count -l, there's like 8,500, almost 8,600 of them. So the next component in the container strategy that I want to talk about is the Docker daemon itself. The Docker daemon is really responsible for managing control groups, orchestrating those namespaces, and all of those other things that I've talked about so that the Docker images can be run and secured. Because of the need to manage kernel functions, Docker itself runs with root privileges, and that's fine, and by that I mean the Docker daemon. It runs with root privileges. Be aware of that, but it's a pretty secure environment. No code is perfect. There will be an exploit at some point. It's just the nature of the war between bad guys and good guys. But it's pretty safe. So there are a couple of considerations when you're running Docker. Obviously, you don't want to allow someone access to your system that you don't trust, right? You want to make sure that you've got some sort of way to make sure that you've vetted folks who are going to be spinning up containers in your environment. The documentation recommends that you add users to the Docker group so that they can run the Docker commands, but with that flexibility does come some risk. Make sure that you only delegate this ability to trusted users, and remember that they can mount host file systems in their container with potentially root privileges. Also, everything that I've talked about and everything that Docker does can also be done via REST API. So, really recommend that you've got updated versions, you're keeping your Docker environment, your management environment, the Docker daemon and so on, make sure you keep that up to date. I can't stress enough. Almost every single exploit that you see that makes the news, that everyone's like, oh my gosh, that is bad. Almost all of that is from two sources. Someone being stupid and plugging a USB drive in at Target that they found in the parking lot, or more often, somebody taking advantage of outdated and insecure code that's network facing. The one about the guy picking the USB drive up and plugging into the computer, we can't help that. I swear, who's the comedian that says you can't fix stupid? I kind of think that's just going to be with us forever. But if you're running an environment, especially an environment that is internet facing, you have got to keep up with your security updates. That's just kind of sysadmin 101. If you are going to expose the REST API over HTTP, please do SSL. Don't expose it except to secured networks or VPNs. unless you really, really, really know what you're doing and you're really staying on top of security. Now, I get that in some places, if you're doing like a public service offering where people can spin up containers and you want to give them API access, you might need to expose it to a public-facing network. Make sure you do it with SSL. Make sure you have authentication mechanisms in place, et cetera, et cetera, et cetera. Don't just leave API gateways open. So Linux kernel capabilities is really pretty cool. And even I've been working at Red Hat for over a decade. Even when I started digging into this, was like, oh wow, didn't realize that this was, this was a thing. Didn't realize this is how this worked. So historically, if I have root access to a machine, if I am logged in as root, I am omnipotent. I can do anything that I want to. And what are we doing within containers? What kind of privileges are we granting folks within their container? Root privileges, right? So you're like, you feel a little uncomfortable about that, like, but hey, it's in the context of their container. They're not going to do anything stupid. But Linux capabilities is a set of controls, very fine-grained controls, that allows services or users with root equivalents to be limited in their scope. It also allows non-root users to be granted extra privileges. So you could do things like have a regular user and you could grant them the capability of the netbind service and they'd be able to bind a service in their container, for instance, to a privileged port. So Linux capabilities is pretty cool. It basically allows you to cheat, to grant more or less privileges than you would normally be able to grant. Now in containers, many of the capabilities to manage network and other services are not really needed. SSH services, cron services, file system mounts, mounts and unmounts, not really needed because those get handled by the Docker service. Network management's not needed and so on. By default, Docker disallows a lot of those root privileges, which is a good thing, including the ability to modify logs, change networking, modify kernel memory, and the catch-all capabilities of system administration. And if you go and read up on the documentation of Linux capabilities, and I'm sorry, this is an eye chart, I'm sure you can't really see it, but I went and I looked under the Docker GitHub page. You go to Docker, daemon, exec driver, I can't even read that, native template, and look at the default template for Linux capabilities. You can see that really only a very small subset of the capabilities that root normally has are passed through to those Linux containers. The net result of that is, even though we're granting users root privileges inside of their Docker container, and we can absolutely go, here's the gun, there's your foot, knock yourself out, they're probably only going to shoot themselves in the foot because we are limiting the capabilities that root has inside of that sudo root user has inside of their container. They're not as likely to be able to damage the rest of the system. And then finally, or not finally, but in addition, one of my favorite topics, like I said, I present on SELinux every year at Red Hat Summit and at really any conference that'll have me, I will evangelize SELinux. I want to talk about what SELinux does. So, Security Enhanced Linux is an example of a mandatory access control system. There are other ones out there. It just so happens that this is the one with which I'm most familiar. I work at Red Hat and that's what we've adopted. But basically, processes, files, memory, network interfaces, memory addresses, ports on the network, and so on, are labeled by the kernel. And there is a policy which is administratively set and fixed. If you look under the /etc/SELinux directory, there's all kinds of cool information about what the policy is composed of, any changes to the policy, and so on. But basically, that policy determines how processes can interact with files, with other processes, with network ports, the kernel, and so on. So essentially what happens is a policy is built, and we have a default policy on Red Hat Enterprise Linux and Fedora and CentOS. We have a default policy that is kind of our best guess as to what makes the most sense in the most common use environments. But basically, the way that SELinux works, the things that we care about from an average user perspective is that SELinux works with labeling and type enforcement. And let me explain how that works. If I've got this mythical service, the foo service, the executable file on disk, if I look at it using ls-Z, which shows me SELinux contexts, If I do ls-z, I might see that it's labeled on the file system with the foo exec type. Foo underscore exec underscore type. That says to SELinux, this is an executable in the domain of foo, and it's a type. So the label is foo exec t. The startup scripts might have the label foo config t. The log files may be foo log t. The data may have foo data t. So, and then when you fire up the process, when we're no longer looking on the file system, but we're actually looking at processes in memory, I do ps-Z. That's a common argument for SELinux. Running in memory, it might have the label foo underscore t or foo type. So those are labels. Those labels are typically defined either by, either we do labeling within the default policy, or an application developer, if they understand SELinux, and I hope that they do, will do all of the labeling. So labeling is just how we identify processes and files on the file system. In memory, they are managed by the kernel. On the file system, they are stored as extended attributes on the file system. So that's labeling. Type enforcement is, now that we know all these labels, these types, it's the rule that says that when a process running in the foo t context tries to access a file on the file system with the foo config t or foo data t, well, that makes sense. You want the foo type process to be able to access its configs and its data, right? That makes sense. But when the process with label foo t tries to access, or also I should say, when it tries to access like foo log t, that works as well. But any other access, unless it's explicitly granted by that policy that's stored under etc SELinux, it's going to be denied. So think about it. If I got my foo process that's running with the foo underscore t label, and that process tries to access let's say it tries to access a file under etc that's got the label shadow underscore t. Raise your hand if you think that's a good idea to grant that access. We will all laugh at you. Right? It makes sense. It's actually fairly straightforward. Linux is not nearly as complicated as people think it is. It's all about what processes run in what context, what labels, and what they have access to. So, if the foo process tries to access, for instance, the directory /home/tcameron with the label user underscore home underscore dir type, even if the permissions are wide open, the policy will stop that access. Even if I chmod 777 /home/tcameron, foo will not be able to access that. Foo process running with the foo underscore t label will not be able to access that home directory. SELinux labels, are, like I said, are stored as extended attributes on the file system or in memory. The SELinux labels are stored in the format of the SELinux user, the SELinux role, and then the SELinux type, and then multi-level and multi-category security. So for the mythical foo service, the full syntax for the label would be user u, object role, foo type, and then S0 and C0. And I'll show you where this comes in just a second. The default policy for SELinux is the targeted policy. In this policy, we don't use the SELinux user or role. That's for multi-level security, like in government organizations, so we'll ignore those. We really only care about the type and the MCS label. Think of the MCS label as extra identifiers, right? It's kind of like port numbers. Like we know that the address for a host is never going to change, but the port number for incoming connections may change, like 80 for web or 443 for web and 25 for mail and so on. MCS is just extra identifiers for SELinux. So in SELinux for containers, we can be very granular about what process can access which other process or which part of the file system. So to be real clear, these are two totally separate labels. Even though they're both user u, object role, foo type, this one has S0 C0 and this one has S0 C1. As far as SELinux is concerned, they are completely different. So type enforcement says that a process with the first label is different from a process with the second label, so policy would prevent them from interacting. Also, there's no policy allowing a process running with those labels to access, for instance, a file system unless it's labeled foo config type or foo content type or another defined label. Neither of those processes, for instance, would be able to access etc shadow or anything like that. Now, on a standalone system running Docker, all of the containers run in the same context by default, but for instance, in our PaaS offering OpenShift, we actually make each instance run with its own SELinux labels. So even if somebody were able to gain access to the process running a Docker container, SELinux would still prevent them from attacking another container on the machine. So it works really well. So let me show you an example. I'm going to emulate an exploit where someone takes over a container. I'm going to use runcon, which says run in the context of, to change my context to that of an OpenShift container. And then I'm going to try to access Etsy Shadow. I'm going to try to write to the file system and so on. So what happens is I do an ID and I'm root. Okay? When I do ID-Z, you can see that I'm running unconfined in a specific context. Then I'm going to take on the SELinux context of a Docker container. So I run con and I change my context, I change the type, and I also change my MLS and MCS labels. And so what's funny is, as soon as I run the runcon command and I change SELinux contexts, it even comes back before I even get a full shell back going, I can't access bash RC. Even though I am root, I've still got the root prompt. When I do cat Etsy Shadow, nope. When I try to touch a file on the file system, not allowed. I try to just do a listing of the home T Cameron directory, and I can't see that as well. I'm totally blocked off from doing any of that. And I think to myself, well, I'm going to be really smart and I'm going to turn off SELinux. So I do set enforce 0. Not allowed. So even though I just changed my SELinux role, I didn't log out, I didn't change user IDs, I didn't do anything like that, I just took on a different SELinux role, it blocked me and I couldn't do anything even though I was still logged in with root privileges. So SELinux is incredibly powerful. It is, I'm not going to say it's trivial to learn, it's not. I mean, you got to put a little bit of brain sweat into it. But seriously, go watch the SELinux for Mere Mortals video. It's 1 hour. I think I encapsulate a lot of the basics of SELinux and talk you through how to get it set up and how to fix things and change things with SELinux. But it is incredibly powerful. I mean, to see somebody who is actively logged in to the console as root, not be able to even change a file on the file system, that's pretty impressive. So let's talk about a couple of tips and tricks. Containers really, at the end of the day, are just a process running on the host. That means that we, as system administrators and systems engineers, have to use that exceedingly rare thing known as common sense. If you're running something on your host, just because it's containerized, remember, we don't deal in snake oil here. It's not a cure for all that ails you. You still have to use common sense. Do have a process in place to update your containers and follow it. I cannot tell you how many times I've had conversations with folks that are like, yeah, our developer created this really cool PHP container and threw it over to us and we put it out there in production. I'm like, really? When's the last time you upgraded it? Huh? You can't fire and forget. Do run the service in the containers with the lowest privilege possible. Drop root privileges as soon as you can. Don't allow root access if you can avoid it. Mount the file systems from the host read-only wherever possible. Sometimes that's not possible. You want to be able to write log files and things like that, and I totally get that. Make sure you're smart in where you grant access to write those log files. Where possible, mount read-only. Treat root inside just like you would treat root on the host. Even though I've talked through how we do segregate and isolate that root account from the host OS, I'm a belt and suspenders kind of guy when it comes to security. I want to have as many barriers to somebody doing something bad to me and making me stand in front of my boss. I don't like standing in front of my boss when something's going wrong. Just call me a wimp. I don't want to do it. And seriously, use some sort of log monitoring capabilities. I don't care if that means you read the daily emails from the root cron job or if you have something really sophisticated in place that's going to do data mining. Watch your logs. Don't just download Bill and Ted's excellent container that you found on the internet from some site in Romania. Yes, I've seen that happen. Don't run SSH inside of your container. I have seen people do this. They're like, well, I'm going to go ahead and build this web service, and I'm going to go ahead and put SSHD in there as well, so I don't have to mess with the admin. And don't do that, because that's one more increase in the service area for attack. It's one more opportunity for you to forget to update. Don't do it. Don't run with root privileges. Don't disable SELinux. Don't roll your own containers once and then never maintain them. It's easy to do, guys. I know as well as you do, right? Sometimes you've got a big fire going and you're doing your best and you're busting your butt and you spin something up and you put it together and you throw it out there and it was an emergency, so you went through an exception and you didn't go through the normal dev and QA and prod type of promotion, and the fire is now out, and now you have dollar day job, which is taking up all your time, and you think, I'm going to get to that. There was something that I was supposed to, but now I got my job to do, right? Don't let that happen to you, because we wind up having these containers out there that have vulnerabilities. And don't run production containers on unsupported platforms. If you run your business on something, my opinion is you should have that big red "oh no" button. So make sure that you're doing it in a supportable and supported configuration. So really, in conclusion, I hope that you will go forth and contain stuff. Containerization is awesome technology. I am really excited. It's been an incredibly fast-moving, super disruptive, in a very positive way, technology for IT. You know, I just like you, man, I've had to bend my brain around some concepts that I wasn't familiar with in the past. You heard me, I came from a Novell environment, right? That tells you what my background is. I'm a dinosaur up here, and I'm having to learn new stuff. But it's awesome stuff, and it's exciting stuff. They make application deployment super, super easy. They leverage some incredible capabilities within the Linux kernel, and by design, they are relatively secure. Obviously, just like any other technology out there, there are some gotchas. As with every other piece of software out there, Docker tech requires some feeding and maintenance. Well-maintained containers, or well-maintained, I should say, containers can make your business more agile, less complex, and if you do it right, safe. Any questions? Yes, ma'am. So if I heard you correctly, the question was, what if we're doing our own Docker registry? Are there any security concerns there? Have a good CI/CD environment in place. Have notifications when your upstream projects that you're building the containers out of rev. Like if there's a security update for whatever the application or framework that you're using is, pay attention to that. And I mean, preferably when upstream revs, have some process in place that's going to suck in that source and start your CI/CD environment, notify you when a container needs to be upgraded, and you guys are going to push the upgrade out. If you've done it correctly and you're doing, the mounts so that the actual data that you're using or web service content or whatever, in theory, you should be able to kick a new container out with practically zero interruption in application service. Yes, sir.
So for the Docker uninitiated, when, as I understand, because it's a layered file system, when, let's say I download like a base Red Hat image, right? And then I build another container off of that, right? And Red Hat revs that image for whatever reason. So merely downloading that new image is insufficient.
Fair point.
Right? What is the next step from that?
At that point, you need to start. Well, there's a number of things that you need to do. You really need to, again, you need to pay attention to and preferably set up some sort of a notification, or even more preferably, an automated process that's going to go get feeds. There's a number of ways to do it, whether it's RSS or whatever, to get feeds of, oh, hey, the underlying Red Hat or Ubuntu or whatever container has been updated. To be real honest with you, you've just asked the $64,000 question. I mean, that is something that everyone out there is struggling with. There are a number of ways to address it. There are a lot of startups that are doing it. I can't talk about it yet, but look for some announcements coming soon from Red Hat. So there are folks who are working on it, but yes, you are right. It is layered. You don't necessarily or even often have just a container. There's going to be stuff that it's dependent upon. But that is a complex question, and I don't have a comprehensive answer, especially not that I can do in the next 3 minutes. Yes, sir.
A lot of the CapAd permissions for Docker, I often find myself using CapAd for Docker, and unfortunately I often end up finding myself just telling it to run in admin permissive mode because the particular CapAd permissions I need are not addressable. Somebody working on that?
I'm sure there is. I have not heard anything about that. Okay. So is what you're saying that when we do the capabilities filtering, you're saying that it's too restrictive?
Well, like say, if I actually need to run something in the container in a VPN.
In what? I'm sorry?
On a VPN.
Okay.
And that requires access to not just the network, but my routing tables, right? I can do capadd netadmin,
Right.
but I can't do capadd routing. And so I
Right.
end up having to do capadd admin and give it full admin permissions.
Right.
And I was hoping that somebody was working on adding additional discriminatory permissions to capadd.
Is
'Cause I
someone-
haven't seen a lot of activity lately.
Yeah, is someone, I'm almost positive there is, as to who that is. I haven't heard off the top of my head, but I will say, and I'll say this to you and I'll say this to anyone else, when you run into limitations like that, because that's valid, that's totally valid, I get why you're saying that. Open a bug, either with us if you're using ours, or with upstream Docker, or whoever's version you're using. Open a Bugzilla report or a trouble ticket so that we know to do it. So, all right, was this helpful? Okay, good, because this is kind of a new presentation for me, so I want to make sure that it was, I'm not the only one who was like, I'm not sure what all this stuff does, so that is fantastic. Guys, I got to clear the room. I think we're out of time. Yes, we are indeed out of time. Thank you very much for coming and for giving me the opportunity to talk to you.